Hello, everybody, and good evening, folks. Myself, Dr. Mahantesh K, Associate Professor, Department of Electronics and Communication Engineering, SJBIT Bangalore. Today, I'll be giving a webinar session on digital image processing using Matlab on Take It Easy webinar series. Firstly, I would like to introduce what you mean by digital image processing. And these are a couple of objectives which you're going to learn at the end of this session. That is, you are going to understand digital image processing first and image formation and acquisition, and to realize fundamental steps in IP, that is image processing and its components, understand image sampling and digitization, images and its types, and finally, whatever algorithms or whatever processing steps we come across during this session will be demonstrated using Matlab. And as a complementary, we'll be working on graphical user interface. So again, I welcome you all to this session. I hope I am audible to you guys. So just kindly please respond on the chat box saying whether it's audible or not. Say yes or no on your chat. Okay. Fine. Thank you. Now, before we start this session, I just want to introduce digital image processing. It's the use of a digital computer to process digital images using a set of algorithms. As it is noticed as a subcategory or field of digital signal processing, digital image processing has many advantages over analog image processing. The generation and development of digital image processing are mainly affected due to three factors: the development of computers, second, the development of mathematics or mathematical models, especially creating and improving discrete mathematics theory, and the last is obviously a demand for a wide range of applications in the environment, agriculture, military, industry, and medical sciences has increased, and it is more vulnerable nowadays. I would like to take up a very basic question today. Like, information is the fuel of 21st century and data analytics, the combustion engine, and the new economy. So here data is the new oil to any industry. So what is the data that we are speaking about? Is it a text or an audio, a video, or an image, or you will be surprised to see whether it's a combination of all the above four. Here, text as well as image are time independent components of data, whereas audio and video are time dependent data. And we are going to choose image as a part of interesting concept where we are going to process that image and see to it like what are the different entities of image and how to process it. As somebody said, a picture is worth 1,000 words. If you're looking at this image, it's an individual perception. Like somebody is trying to see a fish in this image, somebody is trying to see a droplet, anchor, building, drought situation, or somebody would have an intention to express this image is talking all about a global warming. That is why an image is more tricky and more conditional in explaining the image itself. It's a contradictory statement, like it's difficult to explain image as well as a picture or an image can be explained using 1,000 words, and vice versa. 1,000 words are not sufficient to explain any image. So why digital image processing? There are two simple reasons. The first is humans understand image, and on the contrary, we are trying to make machines understand. Why? Because image is a major input to any automated computers or any automation industries. So image sensors are going to be very crucial. So I understand image. So I want to make a computer to understand the image and try to analyze it. And the second simple reason, we have so many mathematical models like linear algebra, statistics, and many others in order to deal with designing the image processing algorithms. So these are two simple reasons why we are actually looking forward to understand digital image processing. And this is a simple image or a blocks which we are trying to explain. And in digital image processing, we try to import the image using image acquisition tools. Here I have made use of a simple camera to acquire the image, and I've used a couple of algorithms. I call it as a digital image processing system, which processes the image which has been acquired in a 3D world around us. And the processed image, if there's an introduction of or evolution of semiconductor devices and image sensors, nowadays it has become more cheaper to capture an image or capture a scene through a digital devices. And analyzing or manipulating the images there, hereby we introduce so many mathematical models or algorithms in order to manipulate or to analyze the image, and in order to generate the output which is a semantic in nature, semantic, or which is visually more interesting. uh, Sorry for the disturbance, there was a small technical interruption due to a showers in Bangalore today evening. Okay, let us just continue. As I was saying, digital image processing, it processes the digital image by means of a digital computer, and it acquires an image through a digital sensor. And I have a digital image processing system to focus on a water droplet here, and that gives an output as a water droplet, which is a processed image. Yeah, there are so many image processing applications. It has been classified into two: biology, nuclear medicines, law enforcement, defense, and industrial applications. Whereas there are many things which comes under machine perception, where we are trying to actually train a machine by giving an images as an input and try to make an analysis and allow a machine to decide what is the necessary steps to be taken in order to based upon the image analysis. The first and foremost is you which has been mostly observed in photopic or bright light vision, and cones are responsible to observe or absorb the color. And whereas rods are sensitive to low illumination level. It is also called as photopic or dim light vision, and rods are responsible for scotopic vision. To have an example, if you are looking at a tree in the midday, say for example at 12 o'clock in the noon, it would appear like this, okay, where you can perceive the colors through cones, and that is called as bright light vision. Whereas if you try to observe the same tree during dim light, say around 6:30 or 7 p.m. in the late evening, so I could rather just observe only the outline or the features of this tree, but not the actual colors inside this tree. It will not be observed. I call it as a scotopic or dim light vision. Whereas if I can observe the colors, it is called as a photopic or a bright light vision. So cones are more susceptible to color, whereas rods are sensitive to low illumination level by defining only the boundary regions of any images or object. I am telling you all these things why? Because I will be in the later session will be using these concepts in order to identify the outline or the boundary, to define a boundary of an image or an object. There are so many image acquisition tools. I've tried to list a couple of them. It has been again broadly classified into EM based sources like electromagnetic energy spectrum as a source. We are trying to capture an image. If you make a patient to swallow a pill which leaves the light, and later it has been captured on a thin filament, and X-ray imaging, gamma imaging, angiography, ultraviolet band, imaging in visible and infrared bands, microwave and radio bands. You can see at the left-hand side, there are so many images been captured using EM energy spectrum as a source. Most of them are in medical sciences, and a few of them in astronomical study. There are other imaging modalities where I use, other than an EM, that is electromagnetic energy source, I use acoustic imaging, electron microscopy, synthetic image, like I can use some different image sensors, CMOS image sensor as an example. I use sound, ultrasound imaging, and I use fractal imaging in order to generate a computer graphics or a computer generated images. Yeah, this is the most fundamental steps in digital image processing. It has been categorized as image acquisition, image filtering, and enhancement, restoration, color image processing, wavelets, compression, morphological image processing, segmentation, representation, and object recognition. Each and every blocks has got its own individual responsibility to understand the image and to process the image in its own way. And this graph has been taken, this block diagram has been taken from digital image processing from Gonzalez and Woods. What is image acquisition? The image acquisition is a process, and it's a fundamental step of digital image processing. It acquires an image, and it is as simple as being given an image that is already in digital form here in this example. Image enhancement or image filtering, among the simplest and most appealing areas of digital image processing. The idea behind enhancement is to bring out details that is obscured or simply to highlight certain features of an interest or region of an interest in an image. Say, for example, changing the brightness or a contrast of an image. Image restoration. Image restoration is an area that deals with the improving the appearance of an image. However, unlike enhancement, which is subjective, image restoration is objective. Here, in enhancement, it is subjective in nature, whereas in restoration, it becomes more objective. Like I have some predefined knowledge about restoring or about enhancing the image, whereas here in enhancement, it is subjective. Coming to color image processing block, it is an area that has been gaining a lot of importance because of the significant increase in the use of digital images over the internet. Okay, and wavelets and multi-resolution processing. It is a foundation for representing images in various degrees of resolution, various intensities, various levels of intensities, where image is subdivided into smaller regions for data compression. And most of the time, this multi-resolution processing is represented as a pyramidal representation. Coming to compression. Compression deals with the technique for reducing the storage required to save an image just in order to acquire a lesser bandwidth or a lesser storage capacity. Coming to morphological image processing, it is the part of a biological image processing which deals with the tools for extracting image components. Till here, from image acquisition, okay, I hope you can see this block diagram. It's starting from image acquisition and till morphological image processing. Okay, the input is an image and the output of these processors are generally an image. Okay, input and output both are an image. Whereas coming to segmentation, segmentation is just like partitioning an image into a discrete, meaningful regions. And representation and description are almost follow the output of segmentation stage, obviously, which uses a raw pixel data constituting either the boundary of a region or all the points in the region itself. So the output of representation and description is given to object recognition. Recognition is the process that assigns a label. Say, for example, the representation and a description has given to object recognition and it labels an image as a car or a bus or a vehicle, any vehicle, to an object based on its descriptor. And all these blocks of digital image processing have been connected to a knowledge base. Okay, so this knowledge base may be as simple as detailing regions of an image where the information of interest is known to be located, and this in fact interacts with all the stages of digital image processing, like saving the information or seeking the information and storing it in the knowledge database. So after this, we have components of image processing. Image processing system is the combination of different elements involved in digital image processing by means of a digital computer. Here we have image sensors. Image sensors senses the intensity, amplitude here in the first stage. It's a bottom to up approach. So yeah, here in this slide. So image sensor senses the intensity, amplitude, coordinates, and other features of the image and passes the result to the image processing hardware. And the hardware is the dedicated hardware that is used to process the instructions obtained from the image sensors. And either you could print, either you could process and it's given to a computer, either you could save it in an external device or a storage, or you can display it on a monitor, or you can print it using a printers. And network is the connection of all the above elements of the image processing system. Image sampling and digitization. So this is a very interesting concept. Why? Because from here onwards, I'm going to use this concept in order to process my digital data. As I have said earlier, is before sampling and digitization, it is analog in nature. You can see image illumination source has been incident on the scene element and it has been reflected, and the imaging system captures it through the lens, and it will be made to fall on an imaging grid or a light filament where the intensity of the reflected light is made to fall on a grid-like structure, mesh-like structure, and those intensity levels been captured on this grid. On this grid will be made use as a samples, and these samples are converted. Like I'm going to give some values to these samples, like amplitude levels to these samples, or give some annotate the sample with some values. You call it as a quantization. So sampling is nothing but dividing or creating this grid, and quantization or a digitization is nothing but assigning the amplitude levels to these samples. Suppose if you observe this dark area, I would assign this dark area as 0 and 0 here in my right hand side. This is an amplitude levels. Whereas you can see a bright spot here at this, and I can assign these bright spots as 255 values. I'll assign some values to this bright spot. Since it is bright spot, it's white, I assign it as 255, and this is dark, I assign it as 0. So this fixing up the amplitude levels to these samples, you call it as digitization and sampling and quantization. So ultimately, what is that I am trying to look or trying to have after digitization? I will have a matrix, a two-dimensional matrix with an elements of a pixel or an intensity level. Okay, so what is an image now? We can come to the conclusion. So what is an image? An image is defined as a two-dimensional matrix or a function f of xy, where each matrix elements is a pixel, where it holds an intensity levels or intensity values, which was absorbed on a thin filament, which has been reflected by a scene or an object. So here I say x and y are spatial coordinates. X and y are spatial coordinates, and amplitude level which is present in that xy coordinate is called the intensity. Here 100 is the intensity. I've just carefully selected a small portion of this image, which is a seafront residence in Naples, Italy, and I have enlarged this part. I can observe these are the values in this small part of that image. So understand what is an image. An image is defined as a two-dimensional matrix or a function of f of xy. We have different types of digital images. Here, this image, this is a binary image. You can see the matrix here. The matrix is, of course, it is in terms of ones and zeros, because there is a transition of values from 1 and 0 or 0 and 1 in binary image. There is only one matrix. Whereas if you come to gray image will have a transition of intensities varying from 0 to 255. It has got a 0 to 255 transitions with one matrix. So this entire image is the matrix, and you have the transition of picture elements or an intensity levels varying from 0 to 255. Coming to a color image is a formation of, or it's a color image is due to three different matrices of primary colors, that is R, G, and B, that is red, green, and blue. You may see the image, you can see a small representation of RGB matrices. Again, each RGB matrices varies, the elements of RGB matrices varies from 0 to 255. The color image has got three matrices. Gray image has got one matrix, intensity value vary from 0 to 255. Binary images have got one matrices, the intensity transition from 0 to 1. Again, extended to another type of image. It is an indexed image where you can see this table. Again, it's a representation of R, G, and B columns, but I can index one value. I can index this RGB values with an index of 5. Say, for example, this is an index 5, but it represents three different colors, and this index is taken to represent any image. Can you see this now? So the 5 is represented. It is an indexed representation where 5 reveals three different values indicating red, green, and blue. So this is called as an indexed image or dictionary-based image. Coming to other type of image, that is multispectral and hyperspectral images. Multispectral images have got pixel intensities which are discrete in spectrum, whereas hyperspectral images has got a continuous spectrum. You can see there are many frames or many matrices in order to generate an hyperspectral image, just like we discussed in B. Whereas here in this hyperspectral images, I have several such matrices which has been captured at different wavelengths, okay, which has been captured at different wavelengths. And this pixel intensity, likewise, this is the last frame been captured using 700 nanometer. So this has got a continuous structure where the pixel intensities is the overlapping of different frames. Most of the times, this hyperspectral imaging is used for satellite images or in order to capture an image by using a remote satellite. Okay, so this was all about image or a digital image, how Matlab. There are so many tools to process a digital image. As I've said earlier, an image which you're trying to process is already in a definite tool or a sophisticated tool in order to process the image or the digital data. Revision toolbox. There are several tools where you can use, and also a Matlab. It is a high-level language for numerical computation, and it is more interactive. It has got vast library packages like including linear algebra, statistics, Fourier analysis, filter optimization, numerical integration, and solving differential equations. It provides built-in graphics for visualizing. So many features that include signal processing and communications, image and video processing, control systems, test and measurement, computational finance, and computational biology. This is a MATLAB console. I have compressed it in one window. It is much similar to other programming languages. I have a typical current directory here where you're trying to execute or implement or save your files. And I have a command window. This is my command window. This is my current directory. And I have a command history, which are my recent commands, which has been executed in my MATLAB. And since I cannot execute most of the program on command window, why? Because it's non-editable window. Is it visible? Just reply it on a chat. If you guys are from electronics and communication or electrical department, or partially from computer, you guys have already come across the MATLAB console. So you have different sub windows on MATLAB console. Since this was a very important part, just say yes or no on your chat window, whether the window is visible or not. Okay, so this is it is if it's not visible. So let me just try to reset my presentation. Give me a few seconds. Okay, how about now? Is it visible? I have only a couple of slides which is left out since due to some technical issues, it's not visible on your screen, either recorded on YouTube. So just let me take some time because these are some important aspects. This is the key area of this entire webinar. So just so I'm receiving no as a response. Okay. Uh, can you just let me know whether it is visible? Just let me know whether it is visible. Actually, if you're online, just let me know whether it is visible. Okay, fine. Yeah, sorry for the interruption. It may be due to this rain factor, the bandwidth has been reduced and we are not able to pump the data into the network. Okay, fine. So quickly, because we are not aware like how much more time this network, this bandwidth will give us flexibility to pump the data. Now, this is the window of the Matlab window which you're talking about. Quickly, this is a current directory, and this is a Matlab desktop, and this is a workspace. This is an editor window and a command history. Okay, these are few lines. These are the initial programming lines which you people will be trying out. So I'll be using this CLC command in order to clear the screen and the command window. I'll use this close all, clear all in order to close all the figure windows, and I'll use this clear all in order to clear all the variables. And here, since I have a predefined or a saved image in my current directory, I'll be looking forward to call a function called IMInfo. IMFinfo, it provides me the image information about sample.jpg. So sample.jpg is an image which has been saved in the directory, and I'm looking for the information of that image. And I have a function called IMRead. So IMRead is a function which reads the image which is present in the local directory. Sample.jpg is the image name. So I read an image by its name and I save it as in a variable called I. So what is an I now? I is an image which has been read. The I is an image sample.jpg which is read, and I is a variable with the data of that image. So I can see the class I. Okay. So here we are trying to read an image which is sample.jpg, which is saved in the local directory. I use IMRead function in order to read the image, and I would use IMShow function in order to show the image. If I execute these lines of command in Matlab, I would generate this output window, which is a figure window, which is going to give or show the image which has been read. So these are RGB plots. As I've said earlier, what is I now? I is a matrix. I is a data of a color image. So color image consists of three matrices. So how to read a first matrix using MATLAB? Since I is my image, it's a color image. So this colon, comma, colon represent all rows or columns. The image is a matrix. It is represented in rows and columns, and I am trying to target my red matrix, that is first matrix. So I'll be representing it by 1. So all rows, all all columns 1. It represents the first matrix, which is a red component. And green, I simply replace this last value by 2, all rows, all columns, second matrix, which is a green. Blue is equal to I of all rows, all column, comma 3, which is a third matrix. So what is red? Red is a red component, which varies from 0 to 255. Again, green is a second matrix, which varies from 0 to 255. Likewise, blue, which is a third matrix, which varies from 0 to 255. I have used some RGB plots, that is subplots, in order to show the first matrix, that is I am show of red, I am show of green, I am show of blue, and this is the output which will be generated. I will be demonstrating this these codes using Matlab and displaying multiple images in one plot. I have read 3 images here. A is equal to IMRead sample.jpg. This is in JPEG format, and .png, .tif as sample 1, sample 4 images as B and C. I can read different format of images, either it is JPEG, PNG, or TIFF. Just you need to remember the syntax. I'm going to use this IMRead with an input argument of the image name or the file name followed by its format using dot notation. And I again use some simple subplot functions in order to plot these images. So how to create an image by random numbers? Just generate some random numbers, save it in a variable, use plot functions in order to show those images being created by using random numbers. Here in this example, I have generated a random numbers, some 256 cross 256 random numbers. And I multiplied all those numbers by the factor 10 so that I get some values within the range of 0 to 256. And I simply plot it, simply show that X. So this is how it appears. Coming to image pixel level processing. Here, the first 4 lines, I have read a sample 2.jpg, which is a sample image. Here I have converted this I, that is a RGB image, into a grayscale image by using a function called RGB to gray. You might ask me a question, sir, why are you trying to convert from RGB to gray? Just in order to eliminate the mathematical complexity or computational complexity, because we have to process 3 matrices if it is an RGB image, whereas now I can process only 1 matrix if it is a gray image. So I convert an RGB image to a gray image by using this function, and now I can see the gray image here as an original image, that is IG. And this is pretty interesting, where I'm trying to invert an image. I use this command IG of. IG is nothing but your grayscale image, which is single matrix, and is nothing but the last pixel. If I refer to this image, this is the last row, okay, and this is the last column. And from n to -1 is to 1. From n to -1 is this index, and n to 1 is this index, and all columns. That means all column values from this end to this end will be inverted. So if I use this command, id of end colon -1 to 1, colon is nothing but a column, values of all columns. And this is the resultant image, that is an inverted image of this original image. You can see all the intensity values from this corner has been shifted to the north, whereas here it has been shifted to this north, and likewise all the other pixel intensities has been reversed. Coming to image cropping, you may crop the images, the pixel values of the object if you priorly know this axis values. I have read an image as sample2.jpg, I am read, and I have converted it to gray, and I have plotted it. Here, I have given the index values here. Here I have given some axis values, coordinate values, 80 to 220. Assuming this is an image of size from say 700 cross 700. So 80 comes to this row, 80 is this line, and 220 is this column. So 80 cross 220, okay? So likewise, I can try to fix up the coordinates. Knowing the coordinates, I can crop it. So this is pixel intensities or the coordinate values, and this particular image will be cropped. 80 to 220 is the row, 80 to 220 is the column, and this is the image which is the cropped image. There are some couple of plot commands. This is quite similar, which we have used in previous programs. So I'll not be explaining this stuff. So I'm just concentrating on the crucial commands of the pixel intensity processing. Image rotation, I have the function called imRotate. Here, imRotate will take two input arguments. The first argument is an image. The second argument is the degree of rotation. Here I have mentioned it as 45, and I is a sample image and J is the rotated image. So I is the sample image which is shown at the left hand side, and J is the rotated image by 45 degrees, which is shown here as the rotated image. Image cutting, I can use imCrop. Instead of giving the index values here, I have given the index values or coordinate values. I can directly use imCrop function and directly an image, which allows user to crop the image. This is the manually cropped image, like which allows user to select the coordinate values, and that will be stored in K. imCrop is a function which allows user to select the coordinate values from the image to be cropped, and K is the cropped image. Distance measures, I will exclude it from this presentation because this is not required for time being. So guide in Matlab, how to use GUI in Matlab. I will be demonstrating it on using Matlab tool. So I shall quickly switch on to the Matlab tool. If you are able to see the Matlab editor window, just say yes or no on your chat window. Are you able to see the command window? Are you able to see the command window on your screen? Okay. Akshay, just let me know whether are you able to see this command window. Okay, fine. Now, what are you going to do? I'll show you a small example on my editor window. I have created my GUI application already. I just need to run this GUI application. So I'll just show you the front end of this application. Okay, I think now it's visible for you. Okay, fine. So this is a simple GUI application which I've created for the demonstration purpose. Just give me 10 minutes more time. I'll not take much time for processing, giving instructions on using GUI. So this is a front end window, how it appears. And if I click on this, there are three push buttons. Remember, there are three push buttons. One has been created by using read an image RGB to gray. Second push button is invert. Third push button is rotate. The same functions what we have executed or implemented, which I've shown it on the slide. So now I have used two axes. This is the first axis, axis one. This is the second axis. which gives me two types of output. This is the original image and this is the processed image. This is how the simple digital image processing application looks like. So if I click on this push button, so it will allow user to enter an image, or it will allow user to select an image, browsing an image. So I will be selecting a sample.jpeg image from a browser, which is located in the same directory where I've created this GUI application. Now the image has been read and it will be converted from an RGB to gray, and original image is appearing in the first axis, whereas the gray image is appearing in the second axis. Now if I push a second push button, it will give me an inverted image. The first original image will be an original image, and the second image is an inverted image. Okay, since we are facing a lot of difficulties in sharing the data or sharing the information, so I have received an instruction from the session coordinator to wind up this session, so that we'll have a recap on our previous session, and we shall continue using Matlab and try to execute some Matlab commands directly in the next session, able to show or share the slides. So thank you, Akshay, and thank you, PIE community, and share all the possible applications on a single window, and will be more effective in the next session. And thank you, Akshay, for creating this opportunity, and for being so kind enough for me to reach out and to give me this opportunity to deliver a session on digital image processing using Matlab. Thank you, Akshay. So if you have any doubts so far what you have received,